Literally, we're going to just rewrite every equation. It's like we're reorganizing everything. Welcome back to 1.4, rewriting equations. Woohoo, rewrite. And I have my new pen that I get to get used to. That looks like we went to... Oh. Uh-oh. Oh gosh. My cat just got his collar stuck in his mouth, and it made him very angry. Okay, I got a pile of animals and not very much time because Lacey's on her way home. Let's do this. Now, I want us to look at a new definition that's called a literal equation. Now, a literal equation is literally just an equation that has two or more variables. And we get to solve, just like yesterday, in terms of two or more variables. And all the time, our answers aren't going to be singular numbers. They're actually just going to be different forms of an equation, which is actually way more fun and way easier. So for example, if you see here, it says rewrite the equation. Sorry, rewriting the equation. Solve the equation 2y plus 5x equals 6 for y, which means anything that's not y needs to go away and go to the other room. Y is not in a very good mood. So the first thing is we move all the things that are farthest away from y away. This would be 5x. Ding ding. If we move him, we'll subtract 5x. How is 5x related to y? It's addition and subtraction, so we do the inverse operation of that. And that simplifies, so we're just left with 2y equals 6 minus 5x. Now, we are left with 2, and y is like, 2, I don't want to hang out with you. You need to go to the other side. And 2's like, but I multiplied against you. He's like, I know. And divides them away. Divide both sides by 2. Up, they did that for you. When you do that, 2 disappears, and we're left with 6 minus 5x over 2. If you're wondering how in the world they got from 6 minus 5x all over 2 to 3 minus 5 over 2 times x, you gotta remember how we add fractions, or add or subtract fractions with common denominators. Say that we had, I don't know, 3 over 7 plus 2 over 7. When we add these together, we add the numerators, but we don't touch the denominators. They stay the same. So it would look like 3 plus 2 all over 7. All we're doing in this process is going backwards from this. So what they did is they split up 6 minus 5x over 2 to 6 over 2 minus 5x over 2. And that simplified. 6 divided by 2 is 3, as you see here. And 5 over 2 is its own fraction with x on the outside. So we'll get used to this process. We'll practice. And to this whole simplifying, it's about splitting it, keeping the same denominator, but splitting the numerators. And then you keep the sign that's in between them. See how that's a subtraction right there? Keep that right there. We'll get used to it. All right, let's on your own and solving for y. I'll help you out on this first one here. We would get rid of everything that's not y. We want to get y all by its lonesome on that side. So the farthest thing away would be x. Let's plus x to both sides. So simplified, that would look like 5y equals 10 plus x. And in order to get y all by itself, we divide everything by 5. Now, in order to simplify both sides, this turns to 1, and I'll write the answer on the left side over here. We split it up 10 over 5 plus x over 5. And simplified, that looks like 10 divided by 5 is 2, and x divided by 5 is the same as saying 1/5 x. So y equals 2 times 1/5 x. Sorry, 2 plus 1/5 x. For number 2, we need to move 4x, the opposite of 4x, and how it's related to y is it's being added or subtracted. So we do the opposite. It'll be minus 4x minus 4x. So we get a negative 4y equals 1 minus 4x on this side. All we got to do is divide both sides by negative 4. Negative 4, divide the whole thing by negative 4, and then we have to split it up, just like we did before. I'm going to make this line here. So we get 1 over negative 4 minus 4 over negative 4x. And negative 4 divided by negative 4 would be positive 1. So our answer here is y, you can read that, equals negative 1/4 plus x, because 1 times x is just x. Last one here, we'll solve by going up. We don't usually do this. So we'll do the opposite of how 6x is related to it, minus 6x from both sides, minus 6x. So we get 12 minus 6x equals 3y. And then we solve this by dividing both sides by 3, all the way by 3, and then we split it up to make it easier for ourselves by going 12 divided by 3 minus 6 divided by 3, and this x is on the outside. Simplified, that equals 12 divided by 3 is 4, minus 2x equals y. That's your answer. So it's not a number, but it's just a different way of looking at an equation. This is very important when we learn, as we're learning how to speak algebra. Now, we did a lot of these yesterday, and let's look at this little remember box that's over here. Ding, ding, ding. So it says a formula shows how one variable is related to one or more other variables. A formula is a type of literal equation. Nifty cool. Now they give us the formula for surface area of a cone. It's very nice of them. And that's given as pi r squared. So that would be the area of the base. Surface area shows all the area of the outside plus pi times radius times L, which is the area of all this stuff around the outside. Now, they want us to solve this for the slant height, L, this guy. Meaning, anything that's not L, we need to throw somewhere else. And then they're not going to give us numbers to fill it in. We're just going to end up with a new way to see this formula. We're translating it from like English math to Espanol math for Sofia. Now, first is you get things that are farthest away from L, which would be pi r squared, and you can subtract the whole thing, minus pi r squared to both sides. Pi r squared minus pi r squared disappears, and it's just left over on the left side. Now, in order to get L all by itself, we have this pi and r next to it. We want them to go away, go to the other room. The only way to make them do that is do the opposite of how they are related to L. They are both multiplying against L, so that in order to move them, you divide them away. Goodbye. And it's left on the other side. The whole side is divided by pi r, and you know what? We can just leave it like that, and that's okay. When we have numbers, it's good to simplify numbers. When we have formulas with lots of letters, it's okay to leave it like this. And it's okay to ask as well. These on your owns, 4 is mega easy. Think what you might divide, if we're solving for the red variable, how might we get rid of the 1 next to it? For number 5, also easy. If we're solving for the red variable, what 2 other pesky things might we divide away in order to get rid of them. And lastly, number 6, we'd first need to subtract 2 pi r squared from both sides. And then do some fancy dividing. In fact, I may even finish this one out for you. So that gives us s minus 2 pi r squared equals 2 pi r h. Now let's get rid of everything that we don't like. We'll just be dividing away 2 pi r, divide away 2 pi r. We do this to both sides. I always write it down for both sides so you never forget. Hashtag never forget. That turns into 1, so h is by itself. And simplified over on the left, we can just leave it with all these letters as s minus 2 pi r squared over 2 pi r equals h. Isn't that beautiful? With all the impending doom of weather and not knowing when I'm even going to see you next, we could not have an island after all this rain and wind. But if we do get to see each other again, we'll at least know a little bit more about the relationship of Fahrenheit to Celsius. 2 ways of telling temperature, if you remember. They give us this nifty formula that's here already for us. And by being able to use this formula and solve it for either C or F makes getting the conversion of Celsius or Fahrenheit easy to go both ways. Right now they only, it's really easy if you know what it is in Fahrenheit to then give you a temperature in Celsius. But what if you know Celsius and you want to figure out what the temperature would be in Fahrenheit? Well, we'd have to rewrite the equation as we'll do in example number 3. So, what they did here was merely go backwards. Now you see these parentheses, they act like giant walls, and walls are scary, and we don't like them. But that puts 5/9 as the farthest thing away from F. Not negative 32, because negative 32 is inside this castle along with F. So the very first thing we move is 5/9 by multiplying it by its reciprocal, or 9/5 by both sides. And that simplifies out nicely. Now we have something a bit more familiar, is we just get rid of that negative 32 by doing the opposite or the inverse operation, adding 32, and it turns that to 0. And the way to convert Celsius to Fahrenheit is merely you multiply your Celsius by 9/5, you add 32, and voila, you have your degrees in Fahrenheit. We're going to need to use that equation and the equation in the key idea in just a moment. So they say here, which has the greatest temperature? Convert the Celsius temperature of lightning to Fahrenheit. Lightning, if you can imagine, is hot. But no one really knows what Celsius means unless you're like Karis or Elena Comrie because they're Canadian. So let's convert it into something American like Fahrenheit. We used our handy-dandy formula from earlier, and we're reapplying it. Oh, I can't even draw an arrow all the way down there. We are reapplying it right here. Hey, it's actually useful for something. Now, they got the temperature from lightning off to the left. The temperature of the sun is 11,000 degrees Fahrenheit. Lightning, check it, is 30,000 degrees Celsius. We don't know what that means. Is that warmer or hotter? We're not sure. Let's plug it into our equation and we'll find out. So they probably used a big super calculator and did 9/5 times 30,000 and then added 32. And they gave them 54,032 degrees Fahrenheit, which I would go on to say is much greater. Lightning is much hotter than the sun. So wear a good SPF. Something a bit closer to home to think about is the 7th problem on your own. Room temperature is considered to be 70 degrees Fahrenheit. Suppose the temperature is 23 degrees Celsius. Is this greater than or less than room temperature? Now, no one really knows what 23 degrees Celsius is, but if we put it in Fahrenheit, hey, we'll know exactly what it is. So, if you're American, you can put 23 degrees into our formula up yonder, just like they did in this example. If you really want to be cool, I guess, you can put 70 degrees all the way up into the original formula that they gave us at the very top of the page. So convert either 70 or 23. I suggest 23, as they already did in the example. And tell me, please, which is greater, 23 degrees Celsius or 70 degrees Fahrenheit? Please show your work. Well, I hope things made sense. If it didn't, ask me. We'll work it through. And hopefully we have a school building that hasn't been blown down by the time we watch this and have class again. It's been nice knowing you, Orcas Island. This is Mr. McKelvey, signing off. I gotta work on my catchphrase.